Hello everyone, I am Dr. Rajesh and I welcome you in this video lecture. And in this video lecture, we have to determine the nth order derivative of root ax plus b. So let us suppose that y is equal to root ax plus b, and this root ax plus b can be written as ax plus b raised to the power 1 by 2. Now, so as to find its nth order derivative, we need to generalize, okay, and for generalization we need to determine at least its 2 or 3 or maybe 4 derivatives and then see the elements of symmetry between them. Like we differentiate it one time, what we'll get? 1 by 2 ax plus b, and it will be minus 1 by 2 into a. Now differentiating again, we'll get 1 by 2, it will be minus 1 by 2, and we don't need to multiply it because later at the later stage we will try to see the element of symmetry between them, so we will not multiplying. So what we'll doing, we'll be writing it as minus 3 by 2 into a square. Fine. Now once again differentiate 1 by 2 minus 1 by 2, this is minus 3 by 2 ax plus b raised to the power minus 5 by 2 into a cube. Differentiate one more time, 1 by 2 minus 1 by 2 minus 3 by 2, and it will be minus 5 by 2. It is ax plus b raised to the power minus 7 by 2 into a4. Okay, now we'll try to generalize and see what will be nth order derivative. Look over here, when here is 4, 2, 2, 2 and 2. 2 is 4 times, 2 raised to the power 4. When here is 3, it is 2 into 2 into 2 in the denominator, it is 2 raised to the power 3. When here is 2, 2 into 2, 2 raised to the power 2. When here is 1, 2 raised to the power 1. So what will happen when here will be n? So what will be getting? 2 raised to the power n. Fine. Now you see, when here is 4, here is a raised to the power 4. When here is 3, a raised to the power 3. When here is 2, a raised to the power 2. So whenever here will be n, this will be a raised to the power n. Now see, when here is 4, here is minus 1, minus 1, minus 1. It will be minus 1 raised to the power 3. 1 less than 4. When here is 3, minus 1 into minus 1. It will be minus 1 square. 1 less. So whenever here will be n, it will be 1 less than n power of minus 1. Fine. And you see here, when here is 4, here is 7. When here is 3, here is 5. Upon 2 is present and minus is present in each and every term of this type ax plus b. Minus is present, 2 is present. So when here is 4, here is 7. When here is 3, here is 5. So what will do? If you do the twice of this, it will be 8 and minus 1 will be 7. Twice of 3 will be 6 and minus 1 will be 5. So here is twice of this one, minus 1 will be 4 minus 1 will be 3. So whenever here will be n, so what it will be? It will be ax plus b raised to the power minus 2n minus 1 by 2. Fine. Minus 1 by 2 is same. And look here, when here is 4, here is 1.3.5. This can be written as, if you want, minus 1 raised to the power 3, 1.3.5 divided by 2 raised to the power 4 into ax plus b raised to the power minus 7 by 2 into a4. Fine. And this can be written as 2 raised to the power 3 minus 1 square 1.3, and it will be ax plus b raised to the power minus 5 by 2 into a cube. So look here, of this series 1, 3, 5, 3 terms are present. When here is 4, only 3 terms are present. When here is 3, only 2 terms are present. And what is the series? 1, 3, 5, 2 difference, and so on. Okay, and it is a AP, and you know nth term of AP is a plus n minus 1, d is the common difference. First term is 1, n minus 1, 3 minus 1 will be 2, common difference is 2. So this will be 2n minus 2, it will be 2n minus 1. Fine. So this is the nth term. But whenever here will be n minus 1 term will be present. So if I write over here 1.3.5 and 3 dots, the last will be n minus 1th term. This is nth term. What will be n minus 1th term? Replace n with n minus 1. This is 2n minus 3. So here you will be writing 2n minus 3. So once again I am writing it, minus 1 raised to the power n minus 1, 1.3.5, 3 dots, 2n minus 3 into ax plus b raised to the power minus 2n minus 1 by 2 into a raised to the power n, and divided by 2 raised to the power n. So this is the nth order derivative of y is equal to root ax plus b. And this question is important from examination point of view. This question is important from examination point of view, and you should thoroughly go through this question. Now we will move towards the next problem. This is the second problem, and we have to find yn. So here if we see what is the degree of the numerator, it is 2, and it will be 3 and multiplied with x minus 1, the linear term, it will be having degree 4. So numerator is having degree 2 and denominator is having degree 4. So we can do the nth order derivative if we are having the terms having simple terms like 1 by ax plus b. If the terms belonging of this type are here, so we can differentiate it easily. But of the terms when the x minus 1 cube and x minus 2 are multiplying in the denominator, we don't have any formula for nth order derivative. So for the same, I am going to do the partial fraction and say this is x square x minus 1 cube x minus 2. So by partial fraction, we know that this can be written as a by x minus 1 plus b by x minus 1 whole square plus c by x minus 1 cube plus d by x minus 2. This implies that x square x minus 1 3 x minus 2, take the LCM, x minus 1 cube x minus 2. So what it will be? X minus 1 square x minus 2, and it is a x minus 1 into x minus 2, this is b, x minus 2 c plus x minus 1 cube d. Fine. So this will cancel out. This implies that x square, now open up this one, x square plus 1 minus 2x, x minus 2 a multiply this one, it will be x square minus 3x plus 2 b plus cx minus 2c. Now open this, x cube minus 1 minus 3x x minus 1, and outside is d. Fine. Now multiply this thing, x cube minus 2x square plus x minus 2 minus 2x square plus 4x, outside is a, and this will be x square minus 3x plus 2 b plus cx minus 2c, x cube minus 1 minus 3x square plus 3x, and outside is t. Now collect one more time, you can write it as 4x square, okay, plus 5x minus 2 a x square minus 3x plus 2 b cx minus 2 c, x cube minus 1 minus 3x square plus 3x d. Now coefficient of x cube, it is a and it is d. Coefficient of x square, minus 4a minus 3b, it will be b, it will be plus b of x square minus 3d, and of x 5a minus 3b plus c, and it will be plus 3d, and of constant term minus 2a plus 2b minus 2c and minus d. Now comparing the coefficient of like powers on both sides, coefficient of x cube over here is a plus d, and coefficient of x cube, nothing is present, can you write it as 0? So it is 0, so a plus d is equal to 0, and coefficient of x square here is this one, and here is 1, so it will be minus 4a plus b minus 3d is equal to 1. Coefficient of x here is this one, 5a minus 3b plus c plus 3d equal to 0, minus 2a plus 2b minus 2c minus d is equal to 0. Fine. So this is what we have. This is system of 4 equations in 4 unknowns a, b, c and d. So therefore it can easily be solved, and upon solving them we will get the values. A will be minus 4, b will be minus 3, c will be minus 1 and d will be 4. So you can solve them. Now we'll put these values over here. This can be represented y is equal to minus 4 x minus 1 minus 3 x minus 1 square minus x minus 1 3 plus 4 x minus 2. Now you see over here we will try to find its nth order derivative, and for the same we need to differentiate it 2 or 3 times. Then we'll try to generalize and find its nth order derivative. Now differentiate it with respect to x on both sides. It will be minus 4 and it will be minus 1 divided by x minus 1 square minus 3, it will be minus 2, this will go up and this will be x minus 1 3 minus 1 x minus 4, and here will be minus 3 4 x minus 2 square into minus 1. Now do one thing, differentiate one more time with respect to x. Minus 4 will be as such. I am not going to change this minus, this minus, this minus. They are fixed. They are very much rigid over here. Minus 1, it will be minus 2 divided by x minus 1 3 minus 3 minus 2 minus 3 divided by x minus 1 raised to the power 4 minus 1 minus 3 minus 4 divided by x minus 1 raised to the power 5 plus 4 minus 1 minus 2 divided by x minus 2 raised to the power 3. Fine. Do one more time. y3 is equal to minus 4 minus 1 minus 2 minus 3 upon x minus 1 4 minus 3 minus 2 minus 3 minus 4 divided by x minus 1 raised to the power 5 minus 3 minus 4 minus 5 divided by x minus 1 raised to the power 6 4 minus 1 minus 2 minus 3 raised to the power x minus 2 raised to the power 4. Now we will try to generalize the nth order derivative. Yn. Look over here. Minus 4 is something like, if I say, is a constant, so I'm not going to look at it. Minus 1 and minus 1. Here we have 3 minus, so it is equal to minus 1 raised to the power 3. When here is 3, here is minus 1 raised to the power 3, and 1 into 2 into 3 is 3 factorial. When here is 2, here is minus 1 raised to the power 2. When here is 1, here is minus 1 raised to the power 1. So minus 4 will be as such because it is present in each and every derivative, into minus 1 raised to the power n times 1 into 2 into 2, 3 is 3 factorial, 1 into 2 is 2 factorial. When here is 3, here is 3 factorial. When here is 2, here is 2 factorial. So whenever here will be n, here will be n factorial, divided by, when here is 3, here is 4. When here is 2, here is 3. So whenever here will be n, here will be n plus 1. Fine. Now look at this one. Minus 3 is constant, present everywhere. Minus 1, minus 1, minus 1, minus 1 raised to power 3. Minus 1 means minus 1, raised to power 2 and minus 1 raised to power 1. Minus 3 is a constant quantity, I am not going to touch it. So can I write it as, whenever here will be n, it will be minus 1 raised to the power n into 2 into 3 into 4 is 2 into 3 into 4. 1 can be supposed, because if it is not written it is obvious. So this is 4 factorial. So here is 4 factorial. Here is 2 into 3. 1 is not present, but it can be written into 3 factorial. One more. Here is 3. Here is 4. So whenever here will be n, it will be n plus 1 factorial divided by x minus 1 raised to the power 5. Here is 3. Here is 5. 2 more. So whenever here will be n, it will be n plus 2. Fine. Look, here is 3. Here is minus 1 will be same. Minus 1 raised to the power 3 minus 1 raised to power 2 minus 1 raised to the power 1. So whenever here will be n, it will be minus 1 raised to the power n into 3 into 4 into 5. So we are lagging 2, so that it could be 5 factorial. So I divided it with 2 and multiplied with 2. So this upper one is now 5 factorial by 2. When here is 3, here is 5 factorial, means 2 more. When here is 2, here is 3.4, divide and multiply by 2. This will be 4 factorial by 2. So when here is 2, here is 4 factorial by 2. When here is 1, it is 3 factorial by 2. 3 means 2 more. 2, here is 4, 2 more. So whenever here will be n, 2 more will be n plus 2 and divided by 2. Fine. Look over here, when here is 3, here is x minus 1 raised to power 6. When here is 2, here is x minus 1 raised to power 5. 3 more. Here is also 3 more. So whenever here will be n, so this will be n plus 3. Fine. And similarly, it can be written as the last term minus 1 raised to the power 3. So whenever here will be n, minus 1 raised to power square, it will be n. 1 into 2 into 3 is 3 factorial. When here is 3, here is 3 factorial. When here is 2, here is 2 factorial. So it will be n factorial divided by x minus 2 raised to the power n plus 1. Because you see, when here is 3, here is 4. When here is 2, here is 3. 1 more. Okay, so this will be n plus 1. So now from here you can take minus 1 raised to the power n into n factorial common. So what will be left inside? Minus 4 by x minus 1 raised to the power n plus 1 minus 3. This will go out. N plus 1 is divided by x minus 1 raised to the power n plus 2. Because we know that n plus 1 factorial can be written as, yes, it can be written as n plus 1 into n factorial. So n factorial is common. Minus 1 raised to 1 n is common. This will be n plus 2, n plus 1 divided by 2, x minus 1 raised to the power n plus 3, and it will be 4 divided by x minus 2 raised to the power n plus 1, and close the braces. Why this quantity? We know n plus 2 factorial here can be written as n plus 2 n plus 1 into n factorial, and n factorial is taken outside common. So this is the required nth order derivative. So in this video lecture we have studied to find the nth order derivative of two important problems. So these problems are very important from examination point of view, and that is all I have from this lecture. Very soon I will be with you with my next video lecture. Till then, take care, bye bye, and see you soon. Thank you very much.